I was hoping you could introduce yourself and tell us a little bit about Scion.
Okay, great. Yeah. So my name is Jerry Bueno. I'm a U.S. sales rep for Scion Instruments, and we're a European company. And we are in the chromatography business, and we manufacture mass specs, GCs, a couple other things. We have umbrella companies that do different things like isotopics, centrifuges, balances. But I work for Scion, and we just do chromatography. We have an HPLC. We have two mass specs, and we have a lot of analyzers, custom, basic, GC, FID kind of thing. And and then I know you through GCC, which is one of our biggest conferences down here in Texas and Galveston.
What would you say are the key advantages of using GCMS over other analytical techniques?
Mass spec is sensitivity. It goes like thousands of times better than your traditional chromatography basic, testing equipment. Gets you probably the most advanced technology we could get in our industry is in mass spec. Sensitivity, I mean, down to nothing is questioned, in whatever industry.
How does sample preparation impact GCMS, and what are some of the best practices you see for preparing those samples?
Since I work a lot of oil and gas, mass spec is not a huge part of the oil and gas kind of field, but it is in environmental pharma, which is also our customers. So environmental, sample prep, soil, water, it's like half of the battle, half of the whole project is sample prep because if you kind of start already with differences in dilution or this professor of mine used to say dimethyl chicken fat, if you can't get the dimethyl chicken fat through that machine, you got to do something. You got to dilute it, you got to cut it up, you got to maybe burn it or a million things, but it is very important. And like, I'll walk into a lab and if you see like this organization, their sample prep is bad. It just like you could just tell. I mean, if you go to one of these very modern biotech in California and it's impeccable lab, their sample prep is probably impeccable. I'm not gonna get like very like scientific with you, but I mean that's what I kind of see, man. And yeah, it is. It's a huge part. I mean, without it, you can move to the next step, which is the system, the chromatography, you know the magic.
I was hoping you could talk about some of the common applications you're seeing these days. You mentioned oil and gas. I was
Yeah, yeah,
curious
yeah.
what
So
of interest is going on.
there's organizations like ASTM, EPA, the one down here in Texas, GPA school, which is the oil and gas. So those people decide the method, they decide what you're going to run. So if you're doing kind of cowboy something different, that's R&D, whatever. But these are the people that have like the Bible methods, from like caffeine to aspirin or whatever. Kind of a sales thing that we do now. We're very involved with those organizations like ASTM, EPA, GPA. We go to their conferences, we go to their trainings, and we're involved with them. And so we're part of those method development ourselves and studies. Like we have an ASTM collaboration that we're doing right now, and it's because we are involved with them making these methods that make people happy. So, short answer: those are the people that kind of run that world.
Could you talk about making the appropriate choice of column and stationary
Yeah,
phase for specific
sure.
GCMS analysis?
Not to sound like a broken record, but I would go to those methods that these people make, ASTM, and they have like the perfect column for that application. We have a pretty good column guide that we give people, but I'd rather have an application person talk a little bit and just say, hey, try this or that or this polar one or this sulfur one or this, etc. And there's so many columns nowadays. One of the questions you sent me about what are the improvements and like what's going on now in mass spec. And it was interesting because I checked some couple of things and all the answers were like all the columns are much better. Like all these columns made are like, use them forever, they don't break, they're like your compound's gonna be there, pretty specific. The Restic catalog back in the day was like the Bible for like application and where you find your column. They are still like a big source of information when it comes to picking columns and stuff. Man, I hate to sound like a snob, but I have an application team that probably figure out what column you need. and then sell you one. That would be my job. Go through those questions pretty like daily, where I'll get a customer saying, "I've been using this, Sapelco, this or that." I'm not like, trying to name names, but and then I'm like, "Yeah, well, let me ask my application person," and he's like, "Yeah, show them to try our column." And most of the time, it's either better, the same, or something different. But at least now we're working a little bit closer together. We know about their application. We help them. It's kind of opened up a relationship a little bit more. In fact, we're improving our columns, improving our column guy. Like it's they're really really good. Like modern day compared to people, packing columns and sand and glass and like kind of prehistoric.
That's great to hear. Could you talk about the differences between electron ionization and chemical ionization?
So CI and EI, okay, everything is EI, right? Everything in my spec is EI. Everybody, like 99% of people are doing EI, right? And then we have CI. It is for things that are large, kind of like lipids or fats, things that are not pinpointed exactly with EI, and then you need like a secondary method of confirming. You can use CI, which is like positive and negative, and EI is always positive. So you need a reagent gas, which is another kind of, you need to have a different mass spec. In addition to the mass spec, if you want to do CI, you would have to change sources. All these like engineering and chemical things probably bore you with, but it's just basically a way of analyzing through a different kind of fragmentation using a reagent gas that would be usually isobutane or methane. To be honest with you, I haven't seen CI in like the last 5 years, 10 years, or anyone using it. I'm sure there's some labs very specific in, I don't know, in the cholesterol or lipids or oil that, like in my area, I don't think I have any CI customers. Again, it's just a kind of like an add-on to your mass spec. I mean, most people would prefer to have it. I'm sure in the future there's going to be a different way, not as complicated, to do kind of things that CI was doing with polarity and negative and positive and reference gases and all that.
Could you discuss a little bit about how GCMS can be used both qualitatively and quantitatively in terms of the
Yeah,
information you're
yeah, man.
looking at?
So whether you want to see it in area or in a calibration, everybody's software is like so high end at this point with both those things that it's just kind of like pick and choose what you're looking for. Ratios or signal to noise or retention time or just I'm just giving you things where you'll be like in a report what you have, what's important to your industry, qualitative or quantitative, area. I mean, that's a pretty easy one. All these softwares are advanced with all that stuff that I would leave it up to your software to decide on all this stuff.
Obviously, troubleshooting's likely a
Yeah,
big part of your job
dude,
on
I
the
come
customer
from a
support
service
side.
background and I did 20 years of service with all the big corporations. Troubleshooting mass spec engineers, they're almost like gurus and Jedi's, man. They are just super sharp people that can like, I'm in the GCMS world, but in the LCMS world, you totally have some Jedi's that are just brilliant people at troubleshooting and all these moving parts and leaks and etc. But the most basic problem I think is leaks or just basic stuff that like us do, like didn't tighten something enough or didn't do it correctly or didn't put it, the way you're supposed to or cool it down correctly or take it up slowly. Like just basic stuff is usually us and it's usually us that cause the problem.
I would just be curious to hear the most common issues that you
Yeah,
think
the
are
most common issue,
prevalent.
I would say leaks, but it's pretty basic. Sensitivity, man. I mean, you're running 100 samples every day and your peak is there every single day and all of a sudden it's not there, That's kind of the basic common PM. When was the last time you cleaned your source? When was the last time you calibrated diagnostics? Like our software, we run a diagnostic on everything in the background, and it tells you reds and greens and checks and X's, and like you could just find out what's going on. You have a bad heater, this and that. And we love that about our software, because it's super easy to do. It's part of the troubleshooting. Sometimes you don't even have to touch the instrument, and you know what the problem is. Then you get into maintenance. Has it been cleaned? Did you run some nasty stuff through it? Did you turn it off over Thanksgiving and then just turned it off and left, yeah, probably sucked in a bunch of crap, and now you can't see your peak.
What's the regular calibration schedule look
Yeah,
like?
yeah.
Is it just an
So,
ongoing process?
man, I get that a lot. And some people get very, very like complicated about tuning and tuning gas and so whatever. It depends on what you're flowing through. If you're in a crime lab and you've got blood alcohol, you probably want to have that machine tuned every day, have a log, it's tuned every Monday, blah, blah, blah. If you're in a university, use it 6 months out of the year and then don't use it, and tuning is not important to you, and all your analytes are coming out and your research is done, you probably don't have to tune it too much. I would say it depends. The question would depend if it's academia or like manufacturing, pharma. I'm sure they on top of that every day or every week. Other than that, it just depends on back to like the standard methods. And some people probably do have in their SOPs tune once a week.
You got into the software discussion. I'm sure
Yeah,
that's a large area of advancement, but I was
absolutely.
curious, what else are you seeing out there in terms of whether it's on the
So
software or hardware
yeah,
side, things
yeah,
you're
yeah.
excited?
Obviously, AI talk, like in anything. Our software still have a lot of numbers, a lot of graphs, a lot of calibrations. AI can help, yeah, somewhat, probably make a really nice report, narrow down your library, stuff like that. But I think everything's just going to like online stuff, people remotely doing things with pretty powerful softwares from their houses and running refineries from distant places, and you're almost in front of the GC or mass spec. You're basically not touching it, but you can control everything. I mean, that's kind of like where everything's at. You couldn't do that probably in the oil industry. That's a huge plus.